This question over here. When they tell you that x is equal to a quarter and the gradient of the curve is equal to 3, you have to realize these types of questions, the moment they mention gradients and you don't see dy dx given to you, you know dy dx is going to be relevant. My point is, 4-mark question, if you don't have the full question, sort of how you'd solve it from beginning to end, off the top of your head right now, the moment you see it, you just focus on finding the next step. Think about what's relevant, think about what makes sense to do. So I hope when you look at this question over here, it makes perfect sense why you would want to differentiate over here, because they're talking about gradient over here, and clearly you have a particular equation that can become the gradient, so you go ahead and differentiate this. You differentiate this with respect to x. How do you differentiate this with respect to x? Confirm that you have a half over here times this, because you're treating this like a number, because they're telling you k is a constant. So you're not confused about why a half times 1 over 2k is just going to be 1 over 2k. Or you can just write it like this a long way. You don't even have to simplify it straight away. If you're not confident in how you would simplify this, then you just might as well write, just include that instruction is my point. A half times 1 over k. Properly included that instruction, very good. A half minus 1, negative a half. This differentiates into this. I'm sure you know perfectly why that makes sense. And this just becomes 0 because this is just a constant. It looks like a variable over there. It looks, potentially confusing, but it's really just what? K is just a number. If this were a number fully defined, you wouldn't have any relationship with this with data x, would you? Like if this were plus 7, it just becomes 0, plus 10, plus 69, plus 420, it doesn't matter. If this is just a number, it just gets cancelled out whenever you're differentiating with respect to x, because it's got no relationship with x over here. Anyways, not confused about confirm that you know how this differentiates into this, and then obviously once you get this step, remember the rule they give to you? They're telling you that x is equal to a quarter is definitely going to give you a gradient of 3. And this is where they're testing on, hey, do you remember dy dx is the instruction used to find the gradient at any point of x? So they're basically saying when you substitute a quarter into here, because this is the instruction for gradients, that answer has to be equal to 3. You're supposed to interpret that as, oh, that's going to give me an equation involving k now, isn't it? And if I have an equation involving k, where k is the only letter missing over there, I can use basic algebra. I can use the rules to rearrange for what I want over here, which is to find k. So then without further ado, that's why we included this instruction over here. It's using this information over here, isn't it? As in dy dx has to equal to 3 when x is equal to a quarter. Oh, so we substitute a quarter into there and make it equal to 3, and you can tell this is definitely going to give you an equation. And now what works over here is, how do we get 1 over k just like this? You might be wondering, like, how on earth do I know this simplifies into 1 over k? Commutative law of multiplication. If you do 2 times 3, just simple, okay? Think about 2 times 3 times 4, for example. This is not related to this question. I'm just saying a separate example over here. Just look at this. Is this the same thing as 2 times 4 times 3? Is this the same thing as 3 times 4 times 2? You get my point. Multiplication, as long as the product, all of them are multiplied together, it doesn't matter which order in which you do them. Does it? Is this a product? Do you recognize this as the product? It's quite literally this times this times this. Well, 1 over k is 1 over k. That's as simple as it can be. But can I not just do a half of my calculator, multiply by whatever this is on the calculator? I can key it in exactly like this on my calculator, can't I? Put a bracket over 1 over 4, do the whole thing to power negative a half, multiply that by a half, and that's where you'll find on the calculator it'll give you 1. And if that's 1, that means this thing times 1 is just going to be 1 over k, so that's where you get 1 over k. My point is, you see this, you don't need to be told, right, to simplify it. This thing, key it in exactly like that on your calculator. Type in exactly 1 over 2 in your calculator. Type in exactly a bracket right next to that. Or you could do negative a quarter, negative a half, multiplied by brackets, 0.25 to the power of 1.5, like that. And you're guaranteed to get minus 4 over there if you do it that way. And the rest is pretty straightforward. I mean, come on, 1 over k minus 4 equals to 3. What do we want? We want k by itself. Well, move that to the side, you get this. How do we k by itself? Oh, we could just do 1 over k equals to 7. We could just multiply k to the other side, couldn't we? 1 is equal to 7k, and then k is equal to 1 over 7. Lots of ways you can do that. I'm sure if you're doing AS Math, you're not confused about how this becomes k is equal to 1 over 7. This is where it gets particularly anal. When the algebra over here gets very, very painstaking. But you have to pay very close attention. As long as you realize when they give you this and they want you to find k, you need some sort of equation involving k. Something involving k equals to a number. So when this is your first step, remember this can be the only other thing this can be written as, because this is all they give you to work with, isn't it? You know that the only other thing this can be rewritten as is what? Well, you better actually integrate this to put inside the square brackets. Remember, whenever you do this, it's always going to be square brackets of whatever this integral is, and outside the square brackets, you have these numbers on the outside, which is what we did over here, k squared, 1 over 4, k squared like that. Excuse me, that should be a 2, but I'm sure you can tell, like, there's a k squared over there, yeah? Yeah, my point is, make sure you know how this integrates to become this. How does it become that? Well, you have 1 over k is still 1 over k. A half is the only thing that you add 1 to, isn't it? So it's going to be 3 over 2, and you divide the whole thing by 3 over 2. Great. Negative a half plus 1, a half divided by a half. 1 over k squared becomes, you put an x in front. Remember, because if this is just a number. It's just a straight up number. If it's a straight up number, if this was plus 7, it becomes plus 7x when you integrate. Remember this? If it's plus 10, it becomes plus 10x when you integrate. So the same rule applies if it's just a number, you put an x in front of that. Because this is going to differentiate into this, isn't it? That's how you know for a fact it's the correct integral. If whatever you say is the integral or something, it's correct. How can you know? It means if you differentiate it, you get the original thing over here. Now, once you have this, all you got to do is, well, look at the stuff inside the bracket over here. It looks fucked up. Why don't we simplify this shit first, right? 1 over k. Now, hopefully your algebra is at a point where if you did 1 over k divided by 3 over 2, 1 over k divided by 3 over 2, in your mind, you can already sort of tell it becomes 2 over 3k. If not, you can do this separately on some scrap working paper, 1 over k divided by 3 over 2. As in, you'd recognize, even if you couldn't do this off the top of your head to get this straight away, you could still realize this is definitely something that can be expressed a bit better, isn't it? So my point is you could work it out the long way, and the long way it doesn't even take long because it's just 1 over k times what? 2 over 3, which gives you 2 over, I'm sure you know why it's 3k. That's why it's preferable to turn this into this, where we get this. Obviously this is still 1.5, 1.5. Same thing over here, anything divided by a half is just going to be 2. If you're not sure about that, remember there's a 1 over here, you could use your calculator to do 1 divided by a half, which gives you 2, just like that. Same thing over here, if this is going to be squared, you divide the bottom by 2. Well, excuse me, this is, my bad, this is, you don't need to do anything about that, do you? It's already as simple as can be, right? Once you get into this, you realize everything inside the square brackets is as simple as can be. Well, all that's left to do is substitute this in, minus substituting that in. So we just focus on one thing at a time. Let's substitute that in first. Make sure we write it cleanly, thoroughly, that we indeed correctly expressed what this substituted into there is going to be, which is 2 over 3k times what? We just replace the bracket over here. This is the format, you know what I mean? Like the basic algebra format. If we're going to substitute this in, we better respect that format. We don't put brackets over there. So this first step makes perfect sense. 2 times whatever k squared to the power of a half is, well, 2 bracket k squared to the power of a half. You shouldn't need to be told why we put a bracket over there. Just like over here, 1 over k squared times x is just going to be k squared into here, isn't it? Minus the exact same thing over here like this. So just replacing the x and put brackets over there. And then obviously you can tell over here, this can be simplified, can't it? So let's just focus on this. 2 over 3k is already as simple as can be. However, k squared to the power of 3 over 2, this is where you're tested on our algebra over here. Do you remember this just means these two multiply together? Which is just k to the power of 3, isn't it? Because 2 times 3 over 2 is just 3. So that's just k to the power of 3 times 2 over this is going to be this, isn't it? As in k to the power of 3 multiplied by 2 over 3k is going to be 2k to the power of 3 over 3k. Any confusion? Yeah? Like we're just focusing one thing at a time right now, aren't we? Just like k squared to the power of a half is just 2 times a half over here. That's why it's a 1, which is just a k. Just like k squared over k squared, come on, that's just 1. So done. That's already as simple as can be. Oh, actually, one more step on the next line, right? How this becomes k squared slash slash. See how that became that. But now we're looking at this. 1 over 4k squared to the power of this. Remember this? General rule. ab to the power of 2 is going to be, is that ab squared? Is it a squared b? Or is it going to be a squared b squared? Remember every single thing. Inside, if it's a product, it's going to be everything to the power of the outside. ab to the power of 2 is a squared b squared. So over here, a quarter k squared to the power of this just means a quarter to the power of 3 over 2 times what? It's just going to be a quarter k squared to the power of 3 over 2 just means a quarter to the power of 3 over 2 times k squared to the power of 3 over 2, which is just to the power of 3, isn't it? This, you don't even tell your calculator can do that for you. And this is where you find it's going to be. Type in a quarter, 0.25 to the power of 1.5. That's kind of what's happening over here. If you're multiplying this by 2 over 3, you know how you get 1 over 8? 1 over 8. Is the 1 over 8, can you do on your calculator, multiplied by this, 2 over 3? You get like why the calculation for the 2 over 3 times 1 over 8 is going to help you get this. If you do that, you're going to find it's 1 over 12. And that's why we did k to the power of 3 times this up top, k on the bottom. 1 over 12 just means 12 on the bottom of it like that. It looks convoluted, but it's very basic algebra over here. Just like this, it just means 2 multiplied by whatever 0.25 to the power of a half is, which is 1. And k squared to the power of a half is just 1. And this is obviously 1 over k squared times k squared. You evaluate that to become 1, so you know it's just going to be 1 over 4 left, and that's where you get 1 over 4. Now, the hard part about this question, when you're going back to do this later, you need to make sure, like, you only move on from this question when you're at the beginning of the video, it's blank. You better make sure you have to write the entire thing correctly and then fast forward to the end of the video to see if you got k is equal to 2 over 7. That's what you got to do. Because what you're really practicing over here is every single... It's going to take you probably a couple of takes. Like, it's going to take you multiple attempts, most likely, at least 2 or 3, to be able to fully write this without any bloopers. Any bloopers means you go back to the beginning and you start again. Yeah? Because this is really... You're really going to test your algebra knowledge. This is where you're really practicing those algebra fundamentals. I mean, it's not likely they're going to give you a question this anal, but it's come up in the past, so it makes sense why you would want to practice it, if you can. Which you can. Right. And obviously you understand why this is minus times this, minus times this, minus times this, which is where we get this. And then common sense algebra now, isn't it? K squared, K squared. How do we evaluate this? Isn't that just 2/3 minus a quarter, 1 over 12 in your calculator? So 7 over 12. Done. 2k minus k. This is what I recommend also, right? In the actual exam, if you evaluate 2 things already from the previous line, you cross them out so you don't do overlaps. Do you know what we're talking about over here? 2k minus k, so you cross that out. And the only other thing left to evaluate is 1 minus a quarter. And then you do this minus whatever 1 minus a quarter is, which is 3/4. And that's where we get 1 over 3. And we just move the 1 over 3 to that side to get this, didn't we? You could just do 1 minus a quarter and then move that to the other side to get... You'll definitely get this. Calculator can do that for you. Like, just literally type in 1 minus a quarter and then minus 13 over 12 and you'll get this. And you get why moving that to this side is going to make the right-hand side 0. Okay? Now, once you have this, this is not something you have to do, but I recommend... I mean, why not just times the whole thing by 12 to get rid of the fractions, right? This already, you can tell, is a quadratic. Why not make it a nicer quadratic? Times the whole thing by 12. Both sides, I mean, it doesn't affect the right-hand side, that's why it's still 0, but left-hand side, if you times the whole thing by 12, you see the significance. This just makes it 7. 12 times this is 12k. 12 times this is just minus 4. So now you have this, and then calculator it. You found k is equal to negative 2 or 2 over 7. And what did they tell you about k? What did you realize about the very beginning of the question? Oh, you see how this applies to a and b. K is what? This is what they're testing you on for the final mark over there. And once you cross out the irrelevant one, that's where you get the full 5 marks. That's the ultimate.